Okay, class. So, good afternoon. I'm going to discuss some details on the installation of service entrance, and I will give some introduction when it comes to the three-phase system. Okay, so to start, let's check this picture, this image wherein, as you can see, this is the service drop. The service drop come from the utility provider. So here in Manila, in Philippines, we use the providers, sometimes Meralco, but it is different in other provinces. So okay, going back from that service drop coming from the utility, this will be terminated, as you can see here, terminated in our service entrance. These are now the service entrance going to our line. So the wire is connected here, and then, as you can see, based on the Philippine Electrical Code, we are using service entrance cap. So we have the service entrance cap. This is the entrada. And then this is the piping. And then we have here the meter and then the main disconnect. Okay. So like here, like this one. Okay. So as we analyze the drawing based on actual, it will something be like this. So it will be something like this. I will draw the one line diagram which is normally seen in the electrical drawings. So we have here the service entrance, and then we have here the meter, and then next is the main disconnect. Then of course don't forget about the grounding. Then this will go to the load side. Load side. Okay. So technically this one is this, and then this is this. Okay, then the meter is here, and then this one. So the connection is from here going to the meter, and then going to this NEMA wherein there is a circuit breaker inside, and then it will go here, and then this is the load side. So that's how you will interpret or how you will combine those drawing and based on actual installation. Okay, and then of course never forget the grounding. So here is a blown up detail. This is the meter. So we have here some points. So once the meter is installed, it will be interconnected, and then the current will flow here, going here. Then this is the main disconnect. Main disconnect. Then it will go here. Then this will serve as the load side. Okay. So going down is what we call the grounding. So here in Philippines, we use white color sometimes based on the requirement of our utility provider. Then this is the copper clad conductor or copper clad rod which serve as the grounding. Okay, so let's discuss here. It's all about three-phase system. Okay, so as you can see, we have here three phases. So this one is the phase A, phase B, and phase C, or vice versa, depending upon the configuration of your utility provider. And then this is the tapping point here of our transformers. So here is this is the lighting arrestor. Then it will be connected here. This is what we call the fuse cutout. And then after the fuse cutout, there is a what we call CLF, or the current limiting fuse. Then after the CLF, it will go to the transformer primary bushing. So from there, it will be it will step down. So say for example, this the system is, say for example, 34.5 kb kilovolts, and then it will be stepped down to 440 or 230 or 680 or 380. So it will depend upon the requirement of the client. Okay, so this is the what we call a transformer configuration. So some of the transformer are based on the power system. They can connect it in a delta way connection or Y or Y delta connection, depending upon the application and the application of the client, or the function of what the client applied for. And then the utility company will recommend on what will be the wiring configuration of each transformer, of the transformer banking. Sorry. Okay, so let's take a look at here the next picture. So they are already connected, interconnected here. Going down to this is class the service entrance. This is the service entrance of the structure. As you can see, they follow RYB connection. Okay. Okay. For the three-phase system, as you can see, I have here a detail of a picture, sample image of a three-phase system. So one, two, three. Those three insulator is what we call the suspension insulator. So the main function of the suspension insulator is to avoid the direct contact of this live cable. Class, take note, this is a live cable. Live cable. Since transmission line siya, galing siya sa taas at high side siya or primary side, technically, it can be 32, 34.5 kb, kilovolts, 20 kb, 69 kb, depending upon on the system, on the existing system of the utility provider or the electric energy provider. Okay, then it will be connected again using this clamp, going to the lighting arrestor going to uh, fuse cutout, then fuse cutout going to transformer. So technically, when it comes to the testing and commissioning, installation of transformer, it will take time, and as well as good experience for you to handle the same project, installation or upgrade of transformer, electrical system, blah blah blah, something like that. Okay, so here this is the transformer nameplate, normally 333. Sorry, in this example it is used as 333 kVA. Okay, and then after that, all the wires will go inside the building. So if it's inside the building, the contractor or the management team or the head of the maintenance will be responsible inside. that building. Okay. So here, as a sample again of a picture wherein we show the sorry, we show the service trap, and then this is the service entrance. This is a city box, the current transformer box, and then this is the current transformer reading equipment. So as you can see, it is interconnected here because um, in this box there is a ammeter or clamp meter or voltmeter, wherein this will be the reference of the energy consumption reader. Okay, then after this, it will the wires, all the wires here will enter the building. Then it will enter here directly. So say for example, if this is 4,000 ampere trip, which is very high for a school. So ito yung, this will have our main CB, and then we have here bus duct for the connection of the panel board within the LVSG or the low voltage switchgear. And then next, we have here the normal, and then the for emergency. Because I think the design here is to have a provision for generator set. Okay, so same thing like this. But before we go with the other topic, here if you can see, our main circuit breaker has its own different function as well as trading capacity. Just read the specification inside or on the circuit breaker. Because this one class is what we call the ACB, ACB, air circuit breaker. Why air circuit breaker? Because this knob, as you can see, it will be charged by charging this one. So this one will be charged. You will move it up and down, and then here we'll have the indicator if it is possible to turn on the circuit breaker. It is also an additional safety feature of the circuit breaker. Okay, so as I open this one, we have here the dead one cover. For the meantime, I did not try to open that. I will be using some features before. So this one is the the electrical panel or the low voltage switchgear of my sample. So this is still following RYB. I will check the grounding. So we have here green wires for grounding. And then for the neutral conductor, so yun pa yung wala. So this is the grounding. So sorry, this is the grounding conductor, and then since neutral conductor, so based here in the picture, neutral conductor was not included. Okay, maybe the system doesn't need the neutral conductor since this is a 230 3-phase. So we don't normally use neutral conductor here instead. But if we have a 440 volt system, 3-phase, we can use line to neutral configuration here because once you have a line to neutral connection for 440 volts, we can obtain 230 volts. 230 volts. Okay? And then this is some sample of the power panel 2 wherein we have the dead one cover, then the main, then this one are the branch circuit breaker. And then this one is also what we call panel board. So as you can see there, still following RYB. Then this is the molded case circuit breaker. Molded case circuit breaker. And then these are the branch circuit breakers. Then we also have the grounding. So we still use green color for proper identification. And then this is the blown up detail of a of a circuit breaker. We have a RYB, and then we have here some specification that must be understood prior to preparation of short circuit analysis, as well as the preparation of arc flash designer analysis. Okay, so as you can see here, we have the KE rating. If we are going to use 230, we have 100. If 240, we can use 50 KA. So it will depend. Your design will also depend on the specification, what is the specification needed for a certain application. Okay? So I do hope you understand what I discussed. If you have some concerns and there are some issues you want to clarify, just leave a message and then I will try to answer all with the best of my knowledge. So I think that's all and thank you very much. Have a good day, class.